That's going to be my third improvised introduction of a speaker at this wonderful summer school. It's my great pleasure to introduce to you my very good friend and very good linguist, Sergey Say from St. Petersburg, a keen field worker, a corpus linguist, and an areal-typologist, who's going to speak about Valency classes in an areal-typological perspective, which is by no means the only thing he is busy doing.
Thank you.
So, please, the floor is yours.
Thank you. So, yeah, it's indeed a big pleasure and honor for me to be invited here as a guest lecturer. And when I received this invitation, I was really flattered on the one hand. On the other hand, I was, of course, afraid. Because I don't view myself as a guest lecturer at a summer school like that. Rather, I would prefer to give a regular session talk, but unfortunately there are no session talks here, as I was told. So I had to somehow get accustomed to this idea of this guest lecture. But after a while, I found out that, well, there are some advantages here. So I can make a virtue of necessity. Because I can actually present a regular session talk as usual, but it will be very long, so you will have to tolerate it somehow for 1 hour and 20 minutes. And besides, I'm not obliged to present anything new, so most of the things which I'm going to talk about today have been presented somewhere else. And if I were a session presenter, it would be not quite accepted. But for a guest lecture, I think it's more or less okay. So be prepared. And you don't even have much choice. So if you walk out, you can do that, but you don't have a parallel talk somewhere next room. Yeah? So you are close here for this time, and I'm eager to torture you for a long time. And I hope I won't have the usual problem of the lack of time.
Meeting now.
Okay. So. All right. So the structure of my talk is such that I will start with the background, and it will be like a lecture-like part of this talk, and then we'll go through a particular study which is being around for several years, and I will talk about what I and my colleagues are doing. And so we've got goals and data collection and data mathematics and everything. So it's about what has been done by a group of people where I'm included, and background is more like lecture and introduction. Okay, so what about the background? We will start with the idea of valency and valency classes, and the valency of a verb is the list of its arguments with their coding properties. So quite trivial. The coding properties include flagging, such as cases and head positions, something we're very well accustomed to, and indexing sometimes, some languages, so agreement of cross-references with head marking languages, and very rarely word order. So, for example, if we see German sentence from Lachikov and others, here we see that the notion which is expressed like, that is by a transitive verb in English, is here actually represented with the experience in the dative case, then Kinder, and then the stimulus in the nominative case, and we also notice that the stimulus, rather than the experience, triggers the verb agreement here, so we can identify this verb frame, and it sounds very familiar to us because it's exactly like Russian nравится, and it's not like English-like, but we face some problems with a typological study of phenomena of this kind, because the immediate problem is that coding devices are language specific. So there was something like the dative case in German, but the dative case in German is of course not the same thing as the dative case in Russian or the dative case in Turkish or somewhere else. So if notions such as instrumental case or agreement slot number 3 in some head marking language are language specific, then where can we find a basis for comparison? The usual answer with many studies is, of course, that we can compare these predicates we are looking at with some other predicates that are also available in the same language. And of course, the most famous example of a topology of this kind is the alignment topology. So what's basically the alignment topology is about? The alignment topology is about, for example, we ask questions. If you take a typical monovalent sentence in your language and you've got an S argument there, if it morphosyntactically aligned with the A argument of the basic transitive clause, like with the verb to kill, or with the P argument of the verb to kill. And we know some potential answers. So potential answers are the S is aligned with A, then it's an accusative language, the S is aligned with P, then it's a narrative pattern, not language of course, or with both, and then it's a neutral pattern, and so forth. The same goes with the transitive alignment typology, or getting closer to the data which are interesting for me, it's actually the same logic is behind the typology of predicate possession. So I will use some data from Stassen's work here, maybe familiar to most of you. So it's about how notions such as Peter has a car are expressed in languages. And Stassen actually has, in this map, there's in some other of his works, but here in this map we've got 5 possibilities. And these are pre-established. So before we classify an individual language, we know how patterns might look like. And if we think about these patterns and how they are defined, what they tell us about is whether sentences like Peter has a car are morphosyntactically similar to some other kinds of sentences. For example, in English, Peter has a car is similar to Peter killed a dog. So this means that there is a transitive verb which is labeled here as have, and indeed we've got a black dot where English is spoken, and we see that there are some other languages like that. Whereas in Russian, for example, the usual pattern will be у Пети есть собака, so something which is morphosyntactically similar to у дома стоит велосипед, nearby the house stands there is a bicycle, something like that. So we can classify this as a locational pattern. And we can classify these patterns comparing the notion of predicative possession with some other concepts that are also expressed in these same languages and have this 5-way distinction of patterns. And of course, this map is very nice for any kind of areal interpretation. It does make an areal interpretation. So for example, we see that the Western Europe is an area where transitive have like constructions are very widespread, whereas in the rest of Eurasia they are not, and the topic-based constructions are prominent here, and so forth. So a very short way from initial data to areal interpretation. So, but we need some things to have in our minds before we start studies like that. So for example, we need sets of pre-established gross values, and it mostly works for big construction types. So it's reasonable to ask the question, if you need a person who works on, I don't know, Abaza, you can ask the question, well, how is your predicative possession organized? But if you ask something like, what about the contact, verbs of contact? It's not so very easy because there are many of them and they do not necessarily behave the same and so forth. So it doesn't work for the whole of verbal lexicon, for all the Valency classes. So what's the alternative? The alternative is, of course, the wordlist-based typology. And I will give you, by way of introduction, I will give you some examples. So for example, here, it's from Bottom's study of experiential predicates in European languages. In what sense is it wordlist-based? Because he has a list of 10 pre-established concepts, such as see, forget, remember, be cold, be hungry, be thirsty, have a headache, be glad, be sorry, and like. And based on a priori knowledge of grammar, he identified 2 possibilities for each verb. Sometimes it's classified as 3, but just for purposes of exposition will suffice. It will suffice to have 2 patterns. So the generalized pattern is the one in which the experiencer is morphosyntactically as a regular subject. So like Peter has a headache if Peter is aligned with Peter is dancing or Peter is reading a book, then it means that this is a generalized pattern. I like in I'm cold or I like this shirt in English. But if Peter is aligned with something else, like in Russian "Меня тошнит" or "Mir gefällt dieses Buch" in German or something like that, then it means that it's an inverted predicate. So experiencer is more syntactically aligned with something else. So we have two possibilities. Well, given that there are 10 verbs and some languages allow some variation, like aimer, plaire or something like that, there is a complicated scoring technique. We don't need the details. But after a while, the song arrives, for each language arrives at a particular figure, numerical value, which shows to what extent are generalized predicates widespread among these 10 notions, and to what extent are inverted predicates widespread for the expression of these 10 notions. And again, with that numeric values, and we can analyze them in terms of areal effects quite straightforwardly. For example, here, it's not, is it visible more or less? I don't know. For example, English has 0. What does this mean? It means that we can't find non-generalized patterns. Whatever you take, the experiencer is always the subject. No other pattern, nothing like me pleases something or the like. Yeah. With other languages in Western Europe, so the so-called standard average European languages are more or less like this, although to different extents. And we clearly see a pattern. So this isopath shows more or less clearly, that Western European languages like here are different from Eastern European languages like here. For example, Russian has a very high score for inverted predicates, and Lesbian is far beyond. And importantly, this is indeed an areal signal because, for example, we can see that Icelandic with the Germanic is very different from other continental and Scandinavian Germanic. And within Slavic languages, Czech and Serbo-Croatian and Bulgarian are closer to standard average European than Russian, and it also has repercussions in other domains of grammar. So the area for areal typology, things like that are very productive, and there are many wordlist-based typological studies, and some of them, I've got some quotes here, are associated, maybe the person who has made most of studies like that, which could be relevant for today's lecture, Johanna. And if she were not present here, I would have probably gone further, but again, I'm afraid, so I probably skipped this part and don't retell what Johanna has written on some lexical-based typological issues of this kind. So you have some other references here as well. So this works pretty fine, and sometimes we've got very clear areal signals, so areally adjacent languages are remarkably similar. So I will give you one more example from Haspenmat's study. Again, I'm sorry it's not very well visible, but what Haspenmat discusses is the common pattern which is shared by many European languages in which verbs of emotion are typically expressed as if they were reflexive verbs or as if they were passive verbs like sich wundern, s'étonner, życzyć, or something like that, sich interessieren, s'intéresser, интересоваться, sorry for pronunciation, but whatever, we see the German, French, and Polish, and actually Russian, so удивляться or интересоваться, things like that are the verbs of emotion, which are typically expressed by as if they were reflexive derivatives from transitives, although these transitives are not necessarily very frequent and sometimes they're semantically different and so forth. So morphologically, интересоваться is derived from интересовать, but semantically and functionally, let's say, it's a complicated matter. So we have this similarity and this pattern, which is found in many Slavic and Romance and some Germanic languages, is not very widespread in the global perspective. So when we see the similarity between just 3 branches of Indo-European, we can hypothesize that it's probably a context-induced phenomenon. This, well, at least to some extent, yeah, maybe partly inherited, but definitely language context did play a role. So this is an areal effect. But somewhere as a side comment, Hasselmann actually noticed that the use of, well, these are bivalent, things like интересоваться and удивляться are bivalent, so you have to express the stimulus as well. And for that purpose, you need some prepositions or oblique cases. And what Hasselmann writes is that the prepositional oblique case governed by the reflexive or resultative verb is not predictable. So all of these, like über and an and de and instrumental in Polish, it's just non-systematic rubbish. Yeah, you need to express things like that somehow. But okay, in German you've got über sometimes, but you don't have über in Polish, and it's not even entirely clear what is there in Polish which we can compare with German über. So the only thing we can do is just say, well, there is something, and it's unpredictable, and it's not very important for the comparison. So what I will try to show in the remainder of my talk is that in fact there are things which are important and we can actually study them. So the major contribution to this area is the Leipzig Valency project, so Valency patterns, Paul, and it's their data and their results have been published in these 2 volumes. And again, of course, I could have spent my time telling what other guys have done, and probably they've done more decent things than those I'm going to talk about today. But these are more or less available, and I hope you can have other opportunities to know more about this approach. And there are some dissimilarities which are important for me between what's there in those 2 books and what's in what I'm going to talk about today. But please be aware that there are similar ideas with slightly discrepant outcomes in various, let's say, scholarly centers or projects and so forth. Okay, so their project is based on 80 verb meanings covering all kinds of numerical values from 0 to 3, so from things like it's dawning to things like he is giving this book to his friend or something like that. There are 36 languages. I don't think they were somehow, I don't know, does anybody know if they were, there was any scheme behind the choice of languages? I'm not sure, it doesn't look like that. I remember there are 3 Japanese varieties there, so I don't think it's really thought to be representative of the languages of the world. Anyway, one important thing I will take from which were shared is that they use a very basic definition of what's a transitive verb. So the transitive verb is the verb which is morphosyntactically behaving as the verb to break, period. So just this. So not like high transitivity with prominent agent, volitional, and so forth, acting on some other argument which is non-volitional and so forth, but just break. So we take this verb, and in terms of operationality, it's very simple and straightforward. Although, well, of course you can criticize it. Why break? Why not kill? And, well, basically because it wouldn't make any difference. But anyway, the definition is like that. Okay? So there are many things you can do with the data, like those in Voronovo. For example, you can check Tsunoda's implicational hierarchy of transitivity. So what's the idea behind this hierarchy? The hierarchy by Tsunoda predicted that if we have a list of notions like that, starting with direct effect, with things like kill and break, and perception somewhere in between, like see and look, and then persuade verbs such as search and feeling, love, like, and so forth, and ending with have. Then, if a language uses a transitive pattern for any of these notions, then all the notions which are above this one in this hierarchy will also be expressed by transitive predicate. Okay, that's simple. Okay, so Russian, for example, is not, well, possession definitely not, and maybe there is some variation here and here, but, well, perception mostly yes, at least for C type, so slushes and vivid. Okay, other languages are more restrictive or less restrictive, but the prediction is that, well, generally it will be like two types, transitive on top, intransitive below. So Tsunade made it in basically on basis of, I don't remember how many, but not so very many ergative languages. And now we have a possibility to check it with some real numbers. So that's how it looks like. And of course, break is 1.0 by definition. So it's always transitive. With a definition like that, it couldn't have been otherwise. But there are other verbs that in the vowel database are always transitive, such as, for example, beat and take and hit. But not all bivalent verbs are necessarily so. So, for example, you see something like see, which is not always transitive, so almost always, but not all the time. And then help. And then finally, you see this look at, which was relatively high here in this hierarchy. So higher than search or wait or know or love, but in fact it appeared to be not so very high here. We see that there is really some sort of a ranking, world ranking of transitivity verbs, but it's not necessarily can be formulated in terms of big classes. So, for example, look at and see, which are semantically similar to each other, are nevertheless very far from each other in terms of transitivity and prominence. Okay, so see is much more prominent in terms of transitivity. So it chooses the transitive pattern in more languages than look at does. I think so. That's kind of goals you can pursue with data from Volpel. How do you pronounce this? Okay, so what are the typical problems here? The typical problems are that the word lists are short in word list studies, wordlist-based studies. As I said, in Volpel, it's 70 verbs covering all kinds of numerical valency, and sets of values are very often pre-established. So, for example, transitive, intransitive, derived, non-derived, or something like that. So what are the consequences? We know which verbs are mostly likely to be transitive or not, yes, but we don't know much about internal organization of minor valency classes. So as I said with this example of syntaktic, lots of things. Yeah. So what are the other verbs that take the database along with syntaktic in Russian or something like that? It's not very easily found in Volpel. And genetic and areal factors are not so very easy to analyze in the Volpel because there are just 36 languages. Of course, and they are showing the global picture, but they don't necessarily show the local picture of valency patterns. So that's why I now start the second and last roughly speaking, part of my presentation, which will be about a particular study and some attempts of solving those problems which arise elsewhere. Okay, so what are the research questions? They are, to what extent are valency class systems similar in areally and genetically related languages? How can we identify and measure these similarities and dissimilarities, of course? What's the depth of genetic effects? So is it like, it's the same question as asking how stable are valency class systems. So is it something like which lasts for the whole period when a language family is spoken, or it's something that can change in 1,000 years or something like that? And what's the granularity of areal effects? So I'm not sure all of you are familiar with the idea of granularity, so I quote Johanna again. So granularity is the scale of geographical patterning. The scale of geographical pattern is the size of the areal unit, for example, local, subcontinental, larger than continental, or global, within which the geographical distribution of a feature displays some clear and describable pattern. So, for example, nominal classes has subcontinental kind of aerial effects. We can see this on this map from walls. Well, very simplistic actually. I combined sources, so what Johanna wrote was from her 1992 book, but here we see the data from walls. But yes, we see indeed that nominal classes are subcontinental. For example, there are very rich nominal class systems in sub-Saharan Africa, but not in Northern Africa. There are very rich systems in the Caucasus, but almost nothing in Northern Eurasia, something in Europe. Northern Australia is different from Southern Australia, and so forth. Okay, so there are some subcontinental areas with lots of genders, but just next door there are subcontinental areas which are quite different. Okay, so the granularity is the size of these areas we can see on the maps like this. So some technicalities about the project. So we only chose bivalent verbs. So verbs with 2 arguments, or to be more precise, those verbs which we can expect to have at least or just 2 arguments in languages we study. That's because bivalent verbs are known to be especially prone to show deviant valence behavior. There are 130 verb meanings, so the coverage of verbal lexicon is dense. Relatively, we can include in the database many different meanings, but just one macro area. Or again, today I will only talk about one macro area, but there are not so many languages in the database which are not from this macro area, and this is Northern Eurasia. The reason for this is that we can only rely on primary data. So suppose we would like to include languages from the Andes or New Guinea. I don't think it's very easy to find descriptions of these languages so that you will identify valency patterns for those 130 verbs that we have, or at least substantial part of this set. Yeah, so it's only possible if you have a native speaker, and we don't have native speakers available so very easily across the globe. So Northern Eurasia is much easier. And so, yeah, with Northern Eurasia, it's more or less possible. Okay, I will. No, I won't. So Northern Eurasia. That's the basic. Of course, it comes at a price. So there are many disadvantages, and I have to speak about them. So, for example, the sample is a convenient sample. I rely on availability of experts and speakers. So if you are an expert and you've got access to speakers, it will be very nice if you can provide some more data, but we can't systematically find something like that for languages, even for the gaps in our database. So the word list, of course, can be biased in some ways which we are not even aware of, because we've got those 130. The only advantage I can tell you is that it's big. But still, I now know that, well, there are some meanings that were not included for some reason, and now I understand it would have been better if we had them in our database. Cross-validation is very problematic. So sometimes there is an expert working somewhere in the field, and he or she comes with the sentences, and we discuss these sentences and make some kind of annotation in terms of valency classes. So we eventually classify them into classes, but to cross-validate this, you have to start everything anew. So you can't just check another dictionary or something. Yeah. So it's very time-consuming, and basically it's just one expert per language in most cases. And some meanings can be marginal, not attested in some languages against, so that's the byproduct of having this word list pre-established. So how the data collection was organized. So as I said, there were 100 predicates. Predicates are given in context, so we are not interested in verb lemmas or in seams or something like that. We are interested in the way particular sentences are, particular prepositions are expressed in our target languages. For example, Peter reached the bank, or Peter touched the wall. So we've got, this is number 21 and 22, and we immediately can ask questions like, are these two patterns identical or not? And the answer for English is yes, they are identical. But the thing is that, and we can even ask a question like that and have a nice map. Yeah, so with just two a priori possible values, like yes, identical, no, different. But the problem is that, of course, it's not very meaningful. So, well, just two verbs somewhere in the lexicon, touch and reach. Yeah. Why on earth should we care about this? So maybe I never tried. Maybe we'll give some instant effects. So maybe we have black and white dots on the map of Northern Eurasia. It will appear that these two verbs are identical. Some areas are not identical somewhere else. But of course, it's not the ultimate goal. And besides, if we want to take it seriously, then we have to compare each pair of verbs that we have, and it's 130 verbs, so you can calculate how many pairs, yeah. So many thousands. Okay. As I said, predicates are only those which are expected to be bivalent, and we try to include as many predicates as possible so that we knew beforehand from some prior studies that they are not necessarily transitive. So there are not so many verbs there which are known to be commonly transitive, like causative change of state verbs and things like that. So their translations are always listed from native speakers. There were some exceptions. For example, in the case of Latin, we didn't do that, but for natural reasons. But otherwise, we tried to get to native speakers. And annotation was performed by language experts, and any variation in argument realization was disregarded. Not that we don't know it exists, but for example, let's take this. If it's Peter touched the wall, then in Russian it must be either Петя дотронулся до стены or Петя коснулся стены. We have to choose, and there are some ideas as to how to do this, but basically, after all, just one particular pattern makes its way into the database. So all the rest are somewhere as a comment. Yeah. And the answer to the question whether it's the same as reach depends on which of the verbs we choose, because достичь берега and коснуться стены are the same, but дотронуться до стены is different. So of course it's lots of noise of this kind. Okay, so Valency classes. We identify Valency classes in the same way as other people. So two verbs are considered to belong to the same Valency class if and only if their two arguments are coded by identical devices respectively. So again, we can compare three Eastern Armenian verbs for reach and touch and attack. And what we see here is that in the case of reach, the bank is encoded by something which is again called the dative case here, and the same happens in the case of touch, but in the case of attack, we have a different pattern. So there is postposition bra there. So it's a different pattern. So what's important, again, I hope most of you already understand this, but I want everybody to understand this. This is very important. We have some symbols here. It's nominative plus dative. But the crucial thing is we are not going to use the information that it's labeled dative in this language. It might be number 7 or whatever. So some particularly, some absolutely arbitrary code. What is important though is that the code for reach in Armenian and touch in Armenian is the same, whereas for attack, the code is different. Okay? So we can't ask questions like, what are the functions of dative? Because then it will be like circular. We will ask the next question, what's the dative then? And there is no end in this discussion. With this approach, we can't use lots of data, so additional names are of course based on something, but we disregard it. Okay, do you have a question?
So
yeah. Okay, go ahead. Yeah, of course you're free to ask questions. It's clarification. Okay. Okay. So one class in each language was identified as transitive. Again, as the one which encompasses break. And the number of, the first parameter, which I won't discuss too much today, is the number of Valency classes, and it has a huge range across languages. So from 7 in modern Greek, which is very limited in this respect, to no less than 33 in Abaza, which is exceptional in many respects. Yeah.
So you would count every different preposition as as a different.
Absolutely.
So 7 Valency classes means.
Yeah. So it's possible, and in fact, well, maybe I must have told more about the ultimate goal, the rationale. So when we speak about individual languages, what's typically encountered in descriptions and analytical works is that, well, these coding devices are semantically motivated, which is generally true. We don't want to call it into question. So, of course, if you take something like verbs that take na in Russian, they надеяться на, смотреть на, and things like that. Of course, there is something in common, like, for example, it's something which is metaphorically understood as a directed motion or something like that, so na plus accusative and so forth. So if you have an a posteriori description of this phenomenon, then of course you can identify many patterns and assign some kind of meaning to these patterns. Yeah, they are not random, of course. Yeah, of course, there is some, if you write out of a grammar verbs that take na and verbs that take od. Yeah, оказаться от чего-то something. Of course, it's understandable. So it's directed motion towards something, and what would be metaphorically understood as some kind of avoidance or motion from the source. So, but the question is whether this is robust across languages. So if there are some semantic motivations, are they similar or are they different? So for that purpose, of course, we did need to take individual prepositions into account, because they are all different. So it means that somewhere in the machinery of individual grammars, for some reason, these meanings are classified differently. Yeah, so metaphorical relationships or etymologies are different, and we want to have some overall picture of this. Okay? So 57 languages of Northern Eurasia, covering most families present and some but not all genera present, and we've got the total of almost 7,000 data points. So the data points come, you see it's a huge database with lots of meanings, lots of languages. Theoretically, we have some radio in every cell. Sometimes there are some gaps, but so that may gaps. Here are the languages of the sample. Well, there are some shortcuts, I know. And if you are somehow interested in this topic, I will be very glad if you can contribute your data for this project. And actually, without all those kind of people who are mentioned here in small print, this wouldn't have been possible. And I'm very glad that actually there are some people from this list here. It's Vasilis and Japan. I'm sorry if I forgot. Well, there are many more. In fact, I just I can't find. Okay, so yeah, a big thank you to all those guys, and I hope it's not the end yet. Okay, so we now come to distance metrics. For each pair of languages, we identify a genetic distance, areal distance, and 3 structural distances. How come? So for genetic distances, we used a very basic and simplistic measure. So it was based on walls, maybe not the best source. And there were 3 levels. So if 2 languages are from the same genus, they're at genetic distance 1, so closely related. If they are the same family but different genera, they're at the genetic distance level 2. And if they are from different families, then the genetic distance is 3. So for example, between Eastern Armenian and Azerbaijani, a pair of languages I like very much, the genetic distance is of course 3, so because they are from different families. Okay. Geographic distance was calculated in kilometers between the 2 points associated with individual languages and the coordinates were taken from. Okay, I again understand it's gross simplification in many cases because, for example, for Russia it would have been anywhere around Moscow, and I know that it must be more sophisticated now. But anyway, it gives you some idea about how closely are pairs of languages related in terms of geography. So, for example, and for statistical purposes, we take the decimal logarithm of that. So, for example, for Armenian and Azerbaijani, the two dots on the map happen to be slightly below 300 kilometers from each other, which means that they are adjacent, more or less, not very far from each other, and the logarithmic distance is 2.44 something. Okay, but it's not very interesting. So these are some background things. We will compare our structural differences with geographical and areal factors, but structural distances are much more interesting. So we've got three of them. So in a nutshell, what they are all about. So the first, of course, I can't even pronounce this, but the first distance we have is about how transitivity prominence is there. Is this language, are these two languages similar in terms of the ratio of transitive verbs that they use? As I told you before, languages can use lots of transitive verbs, and languages can use not very many transitive verbs. So if two languages are similar in this respect, then this distance is low. If they are this similar in this respect, then this distance is high. So the second measure is about whether or not the two languages choose the same sets of verbs as transitive. So of course there is a logical relation between the two. So for example, if the distance in terms of transitivity ratio is huge, for example, let's have a little bit of mathematics. Imagine one language has all verbs being transitive and another only has one transitive verb. One is the minimum because by definition rate is transitive. Okay, so what's the measure in terms of transitivity ratio? Well, it will be something like 0.99, something like that. Yeah. It follows automatically that in terms of transitivity profiles, these two languages will be very different as well, of course. Because for every verb, we take language A and it's transitive, and we take language B, it's intransitive, so they're different. So there is some logical connection, but it does not necessarily work like this. If we have two languages, and in both languages, transitive verbs are just 40% of those 130 that we have. What can we tell about the difference in transitivity profile? Well, basically nothing. It can be the case that they have identical sets of transitive verbs, okay? They are similar. Their transitivity is motivated semantically identically in two languages. That's one possibility. But another possibility is that in fact they have 40% of verbs being transitive, but they choose completely different sets with the intersection of theoretically just one verb to break. It's theoretically possible. So there is some connection between the two measures, but it's not automatic. The third measure is most complicated. It's about the most interesting part, I think, about what we have done, and it's about the ways in which Valency classes in general are organized in the two languages compared. Okay, so let's have some examples. We'll take Azerbaijani, and the ratio of transitivity in this language is 0.48. What does this mean? It means that, well, we managed to connect 121 verbs for Azerbaijani. There were 9 gaps for some reasons, so 121. Out of those, there were 58 transitive verbs. So the ratio is like this. So roughly half of those verbs happen to be transitive in Azerbaijani. So in fact, in Eastern Armenian, the ratio is like that. So 0.5. Very similar. So the distance between them is like that. So 0.5. 0.02. Okay? They're very similar. They're averagely transitive, let's say. Okay. So what about transitivity profiles? How it works? For each language, we've got a column of values. So we can say this verb number 1 is transitive, verb number 2 is intransitive, and so forth. We've got this portrait, let's say, lexical portrait. And we can compare these sets using the relative handling distance. Okay, I will ask, who knows what's the relative handling distance? Okay, not so many people. Okay, great. It's very simple actually. So what we do is we take Eastern Armenian data in Azerbaijan. We take the verb to win, and we find out that it happens to be transitive in Eastern Armenian and intransitive in Azerbaijani. Fair? That's a point of departure. Some difference. Okay. Most other verbs are either intransitive in both languages or transitive in both languages. So judging from this list, I only have 10, not 130. I only have 10 verbs here, and we see that in 8 cases out of these 10, the two languages are identical in terms of transitivity for individual verbs. And there are 2 cases where they diverge. So if we only had these 10 verbs, the relative handling distance will be 0.2. Yeah, yes. Right. So very simple. We just take 2 out of 10. Of course, in fact, well, we've got 130, and there are some gaps and so forth. So in fact, the situation is like that. So that we've got this table. 33 verbs that are transitive in both languages, 33 verbs that are intransitive in both, and there are 13 verbs that somehow diverge. So are transitive in one language and are intransitive in the other. So we've got these values. So eventually, in terms of transitivity profile, the distance between Eastern Armenian and Azerbaijani is 0.109. Yes.
What do we do with mismatches in the gaps?
We disregard gaps. We just disregard gaps. So gap is nothing. So if one language has a gap, then we can say if it's similar or dissimilar to a language transitive for the same gap. But happily, we don't have too many gaps. As you saw, there were 600 in total for almost, well, around 10 gaps per language, something like that. So we can survive with that. Although there are some languages which are better and some languages which are worse, but generally it's not very important. Okay, so and as I said, if this distance is low, then the distance in transitivity ratio is low as well. It's logical. So if the distance in transitivity profile is 0, then the distance in transitivity prominence is 0 as well, just mathematically. Okay, so as I told you, the distance between Eastern Armenian and Azerbaijani is like this. It's 0.109. Is it a lot? So imagine you've got a friend of yours, and you answer questions from a questionnaire of 100 questions, and each question has answers like yes and no, and then you do it secretly and compare your results. It's fun. It can be fun. You can check. Oh, you've got yes here. I never thought about this. I thought you would have no as me. Yeah, so you can see if the difference between you and somebody else is huge, and that's exactly what the handling distance is about. But then, imagine there were 130 questions, and it appeared that there were 13 questions which you answered differently. But is it a lot or not? So whether Armenian and Azerbaijani are similar based on this knowledge that there were 13 instances of transitivity mismatch between the two languages. The only source of knowledge here is, of course, comparing these two languages with other pairs of languages that we have. And we've got lots of pairs of languages. So what we can do is take all the pairs that we have, all possible pairs, and you can, it's 130 by 129 divided by 2. So I can calculate it, but it's, okay, you've got your You can tell me what's the figure, but it's several thousand, yeah? So many, many pairs, we can say how well does this particular pair behave relative to other pairs that they are. And in fact, the average, the mean value of this distance between two randomly picked languages is 0.209, so twice as much. So in fact, the transitivity profiles in Armenian and Azerbaijani are closer to each other than in just randomly picked pair of languages. So we can have so-called z-scores, so standardized measure. What this means is that we compare what we observe for this particular pattern and compare it with the mean, and the distance is exactly 0.1. So Azerbaijan and Armenian are below the mean level, and we can also say if this difference from the mean is huge or not based on standard deviation. So we've got this. Eventually, we've got this. It means that yes, the distance between these two languages is smaller than we could expect on average, just for any single pattern. As you understand, what I'm trying to imply all the time is that Azerbaijani and Armenian are similar. And they are, well, something that probably speakers of both of these languages won't be very happy to hear. But in fact, we see that they use transitive and intransitive verbs much more similarly than in any kind of pair of languages we have than, let's say, Armenian and I don't know, German, something like that. Okay. So what's good about these z-scores is that it's completely irrelevant on how we arrived at them. It doesn't matter whether we measured distances in whatever was the mean. So it's something, again, I'm not sure if all of you know what z-scores and standardization is about, but it's something which allows you to say meaningful things about distributions. For example, if you say that, I don't know, the size of a particular horse's hoof is 11 centimeters. Does it tell you anything? For me, it doesn't tell anything. I don't know what's expected. If it's small or big, yeah? It would tell me something if you say its z-score is -1. Because it will say that somebody measured hundreds of horses and found that on average the size of the hoof is, let's say, 13 centimeters. And the range of the size of the hoof is somewhere between 9 and 15 or something like that. So the one with 11 centimeters is below their average, but not so much below the average. Something like that. So it's a meaningful sentence. We can interpret it somehow. And it's the same with the pair of Eastern Armenian and Azerbaijan. We can interpret these data. We see that they are closer to each other than some other pairs that we've got in the database. Yes.
But then your numbers suddenly really depend on the whole set of languages and on the sampling that you have there. So if you have, how do you deal with that?
Well, I understand the problem. I don't have any solution. So it would be better to have like unbiased distribution with languages that we don't even know if we expect languages to be like from the same area or from different areas. I don't see any. Unfortunately, I don't see any solution. If you have some ideas, I would be very glad to hear.
Could you work with sampling in some way in order to assess the smoothness of the sample or something like that?
So like bootstrapping or something.
Yeah, I don't know. Just looking seeing how changing the sample will affect your numbers.
Yeah, I think it's a good idea. I think it's a good idea. And of course, the sample is biased, and I don't know what kind of sample will be unbiased, because even if we have like all the languages of the world, I wouldn't be sure if it works yet, because we can have like 100 languages spoken in adjacent villages, and then it will artificially make the figures lower. Okay. The final distance is the most complex. So what about Valency classes in general? It's the biggest challenge. The distance which we propose is based on entropy. So what's the entropy? Entropy is the amount of information, the degree to which a particular distribution is variegated, let's say. So let's have some examples. That's an imaginary language like this. Happily, we don't have any language like that in our database. So imagine a language just uses transitive pattern for all 130 verb meanings that we have. So no difference between verbs. They are all the same. They are all transitive. If it were like that, then entropy is, well, it's calculated with this formula, but you don't have to care about it. You mustn't be afraid. So it means that the entropy is 0. The least amount of disorder that you can have with 130 verbs is like that. So imagine a hypothetical language number 2. Happily, we don't have a language like that either, which uses as dedicated Valency pattern for each verb meaning which is there. Theoretically, it's possible. So all verbs are different. All take different cases and different combinations of cases and prepositions and things like that. So for a language like that, well, it's the most disordered language you can imagine with 130 verbs, and its entropy will be actually slightly below 5. It's the most you can get with 130 possibilities by definition. Of course, the real languages are somewhere in between. So, for example, French is like this, and its entropy is 1.31. So, like here, we see that, I hope you can read this. It means that most verbs are transitive. You see lots of those. There are many verbs that take de, there are many verbs that take a, and not so many other kinds of verbs. Okay, Lithuanian is much more richer, because the ratio of transitive verbs is smaller, and there are several common cases and prepositions which are used, so the overall entropy is much higher than in Lithuanian. Okay, so I hope you can follow that one. Yeah. So this system is more complex than this one. It's an interesting issue in itself, but what's more important for me is that it also allows one to calculate how different are the languages. Let's say Armenian and Azerbaijani. Here we've got Valency class labels for Armenian, just a fragment of the data, and here we've got the Valency for Azerbaijani. Once again, I'm sorry for repeating this. We can't rely on anything like nominative dative is here and nominative dative is there, because these are two different languages. We can't say the verb tell is nominative dative somewhere and is not nominative dative in Azerbaijan and so forth. But what we can do, we can build a joint distribution. What's a joint distribution? It's a distribution that takes into account Valency class assignment in both languages. So imagine two hypothetical situations. One hypothetical situation is the one in which there is some Valency class system here in Armenian, and Azerbaijani has different labels, different prepositions, but wherever we've got nominative ablative here, there will be something like, I know, case number 5 in Azerbaijani. In this situation, what we will have, what we would have had, a joint distribution which will be similar to both Armenian and Azerbaijan. Okay? Just a minute. In fact, it's not like that, but it's not the other way around either. So the other way around would have been the case if there is no correspondence between the two languages. For example, there are 4 nominative dative verbs in Armenian. So here, 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 and here. And what we see is that in fact 3 of them behave identically in Azerbaijani as well, and only 1 behaves differently. We've got 2 verbs which take preposition het in Armenian, and both of them take comitative case in Azerbaijani. So this means that in the joint distribution there are not so many classes as you could expect it could expect if they were completely unrelated. That's the essence of the joint distribution. Okay? So once again, if the two languages are similar, then their joint distribution is close to both of them. If the two languages are very different, then you've got all types of combinations here and there. Okay? But actual languages are somewhere in between. So there was a question here.
Yeah, maybe it's a silly one. Isn't this procedure kind of the same as the distance between the transitivity profiles, but only we take into account all the other Valency classes
No,
as well?
because with it's a very important difference. So with transitivity distance, I don't know if you accept our definition of transitivity or not, but imagine, just for the sake of the argument that you do, then it's a meaningful question to ask whether touch is transitive in Azerbaijan and whether touch is transitive in Armenia. But I can't pose any meaningful answer, any meaningful question with respect to whether, let's say, be afraid is ablative in Azerbaijan. Because in order to ask a question like that, I have to define ablative somehow, and I can't do that, and I don't want to for that matter. So the only question I can ask is whether it is true that both in Azerbaijani and in Armenian, afraid and let's say leave or despise or something like that behave similarly or not. And if they all behave similarly, then these two languages are similar. But if one of these languages group these verbs together, but the other uses different preposition for each verb individually, then it means that in this fragment of grammar, they are different. Okay? Did I answer the question? Okay.
There's an even more silly question.
Okay.
Or maybe you said it, why don't you use entropy or mutual information?
That's exactly what I'm trying to
No, no, for the combined, for the difference of the two.
Okay. We go to the next slide. That's mutual information. I just wanted, well, I could have said something like, we use mutual information. But I wanted to, as I'm a guest lecturer, I understand it's my privilege to speak about silly things. Some people know beforehand, but some don't, and I thought it makes sense to explain what mutual information is about. So yes, this is mutual information. For those who know it, it was just about this. So mutual information is about how entropies in individual languages relates to the mutual entropy, to joint entropy, so of this distribution. Okay, so in the case of, so once again, you see this figure, if these two languages were completely different, joint entropy would be high or low? Completely different. High. If these two languages were completely identical in terms of Valency cluster organization, what's the joint entropy?
The same as
The same as the entropy in both of them. Yeah. Okay. The same. So if something like that. Okay. I can. In fact, I have figures like this. So in graphic form. Yeah. So imagine a language like X divides verbs into two classes like this, and language Y divides verbs into two classes like this. So their mutual distribution is like that. So here entropy is like this, here entropy is like this, and the formula for mutual information is here. You don't have to care about this too much, but actually their mutual information, actually their joint entropy is small. So when we take the two entropies together and subtract the joint entropy, we've got a big figure. So similar to the entropy in individual language. So what it means is that based on our knowledge of X, we can predict Y very well. Why? So imaginary situation number 2 is that the first language has a system like this, and the other language makes a system like this. So they are completely unrelated. If you know that, if you know that your verb is somewhere on the left-hand side here, can you predict where is this class number 1 and class number 2 in the second language? No, you can't predict it in no way. Yeah, so they are not related to each other. So the joint distribution is here. It's the maximally complex joint distribution you can have with just two classes. And in fact, its entropy is high, and mathematics is just a miracle. It's exactly the sum of entropies that you have individually for these two languages. So mutual information is 0, something which is intuitively, I hope, is understandable. Yeah, so what this means is that these two distributions are not related to each other in whatever way. Actually, the actual situation is typically somewhere in between. Well, here, for example, well, if you are here in the left-hand side, you can predict that probably you will be in this triangle. It is much more likely than here, but the correspondence is not ideal. So the mutual information is not 0, but definitely smaller than the entropy of an individual distribution. Okay. We'll keep some of the mathematics. So we've got mutual information for pairs of languages. We can say if they are similar or not. So big mutual information means they're similar. Low mutual information means they're not similar. We can convert it into a distance metric so that 0 would be identical, 1 will be completely different. And that's exactly the third distance that we have. And it's high if Valency class systems are divergent. Okay, so for Azerbaijani, for example, this third distance is 0.4. And again, its z-score is again the negative figure. I hope you remember that negative z-scores means that the languages are closer to each other than an average pair. That's again the same logic. Yeah. So Azerbaijani and Armenian Valency classes are more similar to each other than two Valency class systems in two randomly picked languages from the sample. Okay, so finally we've got all our methods, we've got all our instruments here. We've got pairs of languages. Okay, that's the figure. I wasn't able to calculate it. That's the number of pairs of languages. Yeah, pairs of languages. And for each pair of languages, we've got genetic, geographical, and 3 structural methods. So what are the results? Okay, the results are like this. All the 3 structural distance metrics correlate positively with both the genetic and areal distance. So, is it a big surprise? Of course, no. You could expect that. But we will talk about more details now. So, what about transitivity profile? So, how languages are transitively prominent or not prominent. The main finding is that the granularity of this phenomenon is subcontinental in size, and transitivity peaks are, okay, we can see it on the map. Transitivity peaks are here in Eastern Europe and in the Caucasus. So don't be confused. I call this measure transitivity prominence, but for some reasons the map shows the ratio of intransitive. So maybe it's confusing, I'm sorry. So here are languages like Slavic and Baltic languages and some Finno-Ugric languages which definitely have lots of intransitive verbs for expressing biographic concepts. And it's even more typical of languages in the Caucasus. Whereas in Western Europe, standard average European languages tend to be more transitive. Yeah, so we see this area here. And although the data are scarce, but I think that Siberia is another huge area to the east of Eastern Europe, which is also characterized by lower figures. So in fact, in the global, and people from Valpal arrive at similar conclusions, and they say that the anomaly is basically here rather than here. So in the global perspective, it's here that we've got lots of intransitive verbs not expected. Transitivity, prominence, genera are relatively homogeneous, but family size effects are not visible. So we've got some box plots here. So these are distances for pairs of languages which are in the same genus. So what we see that languages in the same genus are not very far from here, but languages from the same family and languages which are unrelated to each other have higher average distances in terms of transitivity prominence. What's important for me is that languages that belong to different genera within the same family are not different from languages that are just unrelated to each other. So if these two languages are spoken far enough from each other, then they are not necessarily similar. It's of course we saw it on the map as well. So branches of Indo-European are not similar in terms of transitivity prominence. Those in the Western Europe have high transitivity ratio, and those in Eastern Europe have low transitivity ratio, for example. Okay, so what about transitivity profile? Transitivity profile is something that shows significant genetic signal, not only on the level of individual genera, but also on the family size level. We can see that. So what's important here, again, that was the second metric, about the profiles of verbs which are either transitive or intransitive. So we see, of course, languages from the same genera are similar. No surprise, no surprise here. Some are mutually understandable and so forth. So of course they must be closer than those unrelated. But what's important here is that languages from the same family are not the same as languages which are completely unrelated. So there is some disposition towards special sets of verbs to be transitive or intransitive, which can be stable across families. So for a long period of time, which is longer than dissipation of individual genera. We can also see that on the map. So this is multidimensional scaling. You don't have to care now how this is plotted, but what we have to care is that the languages are colored according to their families, and we see that non-Pakistani languages are together, and we see that Altaic languages are together, and even Indo-European languages, although there are very many of them, are more or less together. And the only family which is misbehaved is the Geographic family, so that Permic and Mordvin and Mari are somewhere between Altaic and Indo-European, which is exactly where they are, I mean geographically, but Anits is closer to some languages of Siberia, like Nana and Buryat and Udija, and Hungarian, surprise, is among the Western European languages, such as Slovene or Czech, or French or German for that matter. And Baltic Finnic are just like nothing else. So Uranic is unusual in this respect, and okay, it's not the only situation where Uranic are misbehaving. Okay, so I'll probably skip this. How much time? Like 5 minutes. All right. So what about the role of geographical distance for transitivity profiles? Let's talk about areal-typological a bit. So we have the following figure, where this axis is the geographical distance, and here is the cumulative average z-scores for distances between transitivity profiles. It's very complicated to understand, but what it says in essence is that when you get far enough, here you've got the average score for unrelated languages, here you've got the average scores from languages from the same family, and here you've got the average distance for languages which are in the same genre. What is important is that the three lines are different. Of course, we know that because the genetic factor is very important, but the areal factor is important as well, because languages that are closer to each other, which are to the left, have lower z-scores. So they are very, very similar to each other until the distance is around 2,000 kilometers. After that, the geographical factor just fades away. Okay? So languages which are close, it works for both languages within the same genre. So if, of course, the levels are very different, but for two Slavic languages, it is more expected to be similar if they are close to each other. For two Indo-European languages, it is more expected, and so forth. Of course, it's more important for this measure whether the genetic distance is high or low, but given a certain degree of genetic distance, geographical distance also plays a role. Okay, so robust genetic signal and areal signal fades away after some distance. What about Valency class systems? So again, as in the first case, we see robust we see robust signal within genre, but families are not. There is nothing similar within families unless they are the same genre. So here, the same again, the same level again.
Can you pull that?
Okay. So next slide. What we've got here, the red one and the yellow one here are completely the same. If you are not in the same genus, the Valency class systems are, well, it doesn't matter if the Valency class system in Romance and Armenian are no closer than in Romance and any non-Indo-European language. But what is important though is the geographical distance. The effect of distance lasts longer. It doesn't fade away immediately after 2,000 kilometers. So there is some continuing effect here and here. The two things, you can ask a question about anomalies here in close distance, but it's the Caucasus. We don't have to care about this. But anyway, what's important is that we don't reach zero until relatively long distances. So areal effect is very important for the organization of Valency classes. Okay, I don't have time, and I only have this last visualization. So it's another method of visualization of Valency distance in terms of organization of Valency class systems, and it groups together languages that are similar. And we see that areal effects, low-level areal effects, are very visible here. For example, we've got lots of Slavic languages like Czech and Polish and Slovene here, but okay, Lithuanian is almost, and Latvian, so related, but Hungarian as well is here. Okay, and here we've got Romanian and Spanish and Italian and Gascon. Don't ask me why Gascon is there at all, but we also got Albanian and Basque. So Basque, in terms of its Valency class organization, is very similar to Romance languages. So the alignment is completely different, the case frames are different, but the transitivity and the choice of organization of verb lexemes into classes in Basque is quite predictable based on data from French or Spanish, for example. We've got, I don't know, here we've got a nice group of guys such as Russian, Ukrainian, Belarusian, but also Hilmari, Erzumovin, Komi-Permak, Komi, and Mokshin. So they're almost very close to each other. Although case systems are completely different, and in fact these are very complex systems of spatial relationships and all and so forth. But given your knowledge of Russian, you can predict after some time Valency class assignment in those languages here. Okay, so here are the conclusions. Transitivity prominence is an areal phenomenon with some continental granularity. Similarity and transitivity profile have strong genetic effects, but not so much geographic effects. So maybe it's mostly a genetic phenomenon rather than an areal phenomenon. It lasts for a long time, and families are relatively stable. Whereas similarities in Valency class organizations, including minor classes, don't show much family size effects, but they have strong areal effects, so that languages that are areally adjacent to each other are similar. So a possible explanation is that Valency patterns change relatively fast, are easily transferable in language context, But languages are relatively stable in terms of those semantic features that account for transitivity and intransitivity. And this possibly means that transitivity hierarchies are family specific. Okay, acknowledgements, many colleagues of mine, and I'm lucky my co-author and wife who actually made many of the articles in this presentation. Many thanks to her. She's not here. And thank you.
I'm afraid we have no time for questions, but only instead of...
Questions? I don't know. I'm sorry. So I hope some of you had your questions in between, and I'm available. I'm available until the end of the